Good afternoon, all of you.
Good afternoon, sir.
Good afternoon, sir.
We were solving numericals on the resultant of concurrent force system, right? So we have solved example in the previous class, and we will solve more number of examples today. Please note down the statement. The angle between two concurrent forces is 90 degrees and the magnitude of their resultant is 2500 Newton. The resultant makes an angle of 46 degrees with one of the force. Determine the magnitude of each force. So there are two forces perpendicular to each other. Let those two forces be P and Q. The resultant of these two forces, magnitude is given 2500 Newton, and it is also said that it makes an angle 46 degrees with any one of the force. So let that force be P. I am taking x-axis along P and the y-axis perpendicular to it, that is along Q. Now if you resolve this resultant, x component of resultant is 2500 cos 46, nothing but force P, right? So force P is nothing but x component of resultant. Similarly, y component of resultant sin 46, that is components. The x component of resultant is nothing but magnitude of force P, and the y component is magnitude of force Q. So calculate the magnitudes of forces P and Q.
Sir, force P
What is force P?
17
36.64 Newton.
Newton.
173.
6.64.
6.64 Newton.
0.64. Right. And the magnitude of Q?
1798.34 Newton.
8.34.
179.
8.34.
Right. So there is another method of solving this. When the forces are perpendicular to each other, you can say resultant is equal to square root of P square plus Q square. So you have R square, that is 2500 square, is equal to P square plus Q square, say equation 1. And also tan alpha is equal to Q upon P, right? Let me say this is alpha, this is Q. So tan 46 is equal to opposite side Q upon adjacent side P. So tan 46 is equal to Q upon P. So this is the second equation. Solving these two equations, you can get magnitudes of P and Q. 3. The post is to be pulled out of the ground using two ropes A and B as shown. Rope A is subjected to a force of 600 Newton and is directed at 60 degrees with the horizontal. if the resultant force acting on the post is to be 1200 Newton vertically upwards, determine the force T in the row B and the corresponding angle theta. It is given that a post is being pulled by two ropes A and B. The force in the rope A is 600 Newton and the force in rope B is T. The resultant of these two forces is acting vertically upwards with the magnitude 1200 Newton. Then you have to find out the magnitude of force in the rope B and the corresponding angle theta. So the resultant of these two forces is vertical. So the 600 is making an angle 60 degrees with respect to horizontal, whereas T is making an angle theta with vertical. So it is X, Y.
Theta is equal to
Yes.
23.74.
As the resultant is acting along y-axis, its x component, that is summation fx, is nothing but x component of resultant is equal to 0. Right? Resultant is acting vertically along y-axis, so its x component will be 0. So resolving these forces into x and y components and taking algebraic sum. X component of 600 is 600 cos 60. X component of T minus T. Here theta is the angle with respect to y. So y component is cos theta, x component is sin theta. Minus T sin theta is equal to 0. So T sin theta is equal to 300. Now the vertical component of resultant, that is algebraic sum of all y components, is the resultant itself, being x component is 0. So y component of 600 is 600 sin 60, y component of T plus T cos theta is equal to R is given 1200. So this gives you T cos theta. .38. So from these two equations, you can get theta and T.
Theta equal to 23.74.
Sir, theta is 23.8.
Right. 23.8.
And T is equal to 743.58.
43.58.
58.
41.
Okay. Right.
Sir, 743.41 is okay.
Yes. Now this you can solve by another method also. Here there are two concurrent forces are acting. So we can use either triangle law of forces or parallelogram law of forces. Suppose if we use triangle law of forces. So these two concurrent forces are represented in magnitude and direction by the two sides of a triangle. Then the third side of the triangle taken in the opposite order gives you the resultant. So this is force 600 Newton acting at an angle 60 degrees with horizontal. Then you have force T acting at an angle theta with respect to vertical. Then it is given that the resultant is vertically upwards. Now for this triangle, let us say OAB. You have angle O as 30 degrees and this angle B as theta and angle A is 150 minus theta. Now using sine rule for this triangle, we have 600 upon sine theta is equal to R is 25. What is R? 1200. 1200 is equal to 1200 upon sine 150 minus theta is equal to T upon sine 30. So solving this, you can have T and theta. And you can also use parallelogram law forces, but that will be complicated. So you can use any method which suits the given example. Determine the magnitude of resultant force for the concurrent force system shown in figure and its direction measured in counterclockwise from the positive x-axis. Counterclockwise means anti-clockwise. So here three concurrent forces are acting in point O. So we have to find out the resultant of this system, magnitude as well as direction with respect to the positive x-axis measured in anti-clockwise direction. So when more than two concurrent forces are acting, we can find out the resultant either by using polygon law of forces or by resolving each force into
Two components, X and Y.
Excuse me, sir.
yes.
Sir, what is the third force here? I missed the diagram. So what is the third force?
Please see the board. Board is visible.
Sir, it's actually somewhat blur. I'm seeing it. So can you please tell me this third force?
Yes.
Angle, sorry, angle. Not force, angle. Yes, sir. Yes, sir.
It is 850 Newton, which is in the fourth quadrant. 850 Newton, making an angle 36.87 with respect to x-axis.
Okay, thank you, sir.
So we have to resolve now each force into x and y components. This is x towards right, y downwards, x towards left, y upwards, x towards left, y downwards. Then taking algebraic sum, say summation fx. Roll number 10. Yes, roll number 10.
Yes, sir.
Tell me the expression for the summation fx. Say starting with 850. What is x component of 850?
850 cos 36.87.
850 cos 36.87. X component of
Minus 750 sin 45.
750 sin 45. X component of 625.
Minus 625 sin 30.
625 sin 30. Right. Similarly, you have summation fy minus 850 sine 36.87 plus 750 cos 45 minus 625 cos 30. Because here 30 degrees is the angle with respect to y. So y component is cos, x component is sine. So summation fx is minus 162.83.
Yes, sir.
Whereas summation fy minus 520.94. Right? So here minus indicates it is 162.38 Newton acting towards left. Summation fx is negative, means acting towards left. Similarly, summation fy 520.94 acting downwards. Now you have the resultant, magnitude of resultant, square root of summation fx square plus summation fy square. Direction of resultant, tan inverse summation fy upon summation fx. Right.
And alpha is 70.64.
0.79 and 72.64.
64.
So this is with respect to 72.64.
Of x-axis.
X-axis, with respect to x-axis.
With respect to x-axis.
So we have now magnitude of resultant, direction of resultant, point of application of resultant, that is a point of concurrence. Now you have to find out the sense. So in which quadrant it is acting?
Third.
Summation fx towards left, summation fy downwards. So it is in third quadrant. So making an angle 72.64 with respect to x-axis. Now you are asked to find out the direction of resultant with respect to positive x-axis measured in anti-clockwise direction.
180 plus 72.
Right. So it is 80 plus 72.64. 252.64.
252.6.
5 concurrent forces are acting at point O. So you are asked to find out the equilibrium of this system. What do you mean by equilibrium?
The force that
The force that brings the
The-
system into equilibrium.
Right. So it is the force or moment which will bring the given system in equilibrium. The magnitude of equilibrium is same as that of
Resultant.
Resultant. Opposite.
direction is opposite. So simply first you have to find out the resultant of this system. Then automatically we can have equilibrium. So to find out the resultant of this system, you have to resolve each force into x and y components. Right? So I will select x-axis along 40 kN force, y-axis perpendicular to it. Here 40 kN is acting along x-axis, 35 is making 70 degrees with respect to x-axis. To resolve the force into its components, we must know the angle made by the force, either with respect to x or y. Now let us find out the angle made by 30 kN with respect to x-axis. So 180 minus 70 minus 80. that is 30
30.
degrees. So 50 kilonewton is making 40 degrees with respect to x-axis. Now find out the angle made by 60 kilonewton with respect to x-axis. Total 180
80.
minus 40 minus 80. That will be 80. Now you can resolve each force into x and y components. Please make a note of the sense of 40 kilonewton and 50 kilonewton. These two forces are acting towards the point, whereas other three are acting away from the point. So here x component of 50 kilonewton will be towards left and the y component is upwards. It's not like being 50 kilonewton is located in the fourth quadrant, x is positive, y is negative. No, you have to see the sense. Accordingly, the sign of these components should be considered.
40 kilonewton minus plus 40 kilonewton.
In which direction is acting along x-axis, but is acting towards the point, point O. It is acting towards left, so it is minus, right?
Sorry, minus, yeah.
X component of 35
Plus 35 cos 70.
35 cos 70, right? For 30
Minus 30 sin
minus 30 cos 30. It is making 30 degrees with respect to x-axis, no? So x component is cos. What about 60? X component of 60 kilonewton.
Sir, actually the board is not visible and I'm not able to see the angle.
But you have the figure with you, no?
80 cos
Minus 60 cos 80, right? And x component of 50 kilonewton, it is again minus 50 cos 40. Then summation Fy. Please check the equation. Y component of 40 kilonewton is 0. Y component of 35 is plus 35 sin 70 plus 30 sin 30 minus 60 sin 80 plus y component of this 50 kilonewton is upwards plus 50 sin 40. Kilonewton. Fy
20.94.
20.9.
994, right? So here you are getting minus, which means 102.73. It is acting towards the left, whereas summation Fy is upwards. Now resultant is equal to square root of 102.73 square plus 20.94 square. Direction of resultant and inverse 102.73.
Resultant is 104.64.
Right.
104.8.
104.85.
104.84. See, by finding the direction of resultant, don't take negative sign over here. It will confuse you. You take only the positive values. Depending on the signs of this summation fx, summation fy, you can locate the quadrant, and accordingly you can define the direction. So here what is alpha?
11.52.
11.51.
11.5.
11.52.
11.54.
With respect to x-axis. Now, resultant is acting in which quadrant? Summation fx, summation fy upwards.
Second quadrant.
Resultant is acting in the second quadrant, making an angle 11.52 with respect to x-axis. So now what is the equilibrant of this system? Equilibrant will act in the fourth quadrant of magnitude 104.84 kilonewton, acting at an angle 11.52 degrees with respect to x-axis. So this is our answer. Please note on this example number 6. 4 concurrent forces P1, P2, P3 and P4 act on an annual ring as shown in figure. Inside and outside diameters are 26 and 34 centimeters respectively. Coordinates of point of application of these forces are indicated in the bracket with respect to the center of the ring. So check whether the system of forces is in equilibrium. If not, find the resultant of these 4 forces in magnitude and direction. So how do you check that the given system is in equilibrium or not? By finding its resultant. So if the resultant is 0, you can say that the system is in equilibrium. Again, resultant means it can be a force or moment, but the given system is concurrent force system. There is no question of moment, right? So the concurrent force system will have only resultant force. So you find out the resultant force. If it is 0, you can say that the system is in equilibrium. Okay, the 4 forces P1, P2, P3, P4 are acting on the ring, and these forces are forming a system of concurrent forces. Now to find out the resultant of these forces, you have to resolve the forces into xy components. Here P3 is acting along y-axis, P4 is acting along x-axis. Now to resolve P1 and P2, see here, this P1 is acting at point A, which is on the outer ring. The diameter of the outer ring is 34 centimeters. So the distance OA is 17, right? I am saying the direction is alpha. And what is the opposite side? That is y coordinate 15. And adjacent, that is x coordinate is 8. Right? Similarly, P2 is acting at point B on the inner ring. So the diameter of the inner ring is given 26. So this radius is 30. Whereas the y coordinate is given -5, so this is 5, and x is 12. Say the angle is beta. You can find out alpha is equal to tan inverse 15 by 8, beta is equal to tan inverse 5 by 12, or otherwise directly you can take cos alpha, sin alpha values in the expression without finding the angle. So starting with P1, x component is positive, y component is also positive. For P2, x component is positive, y component is negative. Now I will write the equation, you please check. So x component of P1 is 85 cos alpha, right? But cos alpha is equal to 8 by 17. I will write directly 8 by 17. 8 is the adjacent side, 17 is the hypotenuse. And x component of P2 plus 65 cos alpha, cos beta. Here beta is the angle with respect to horizontal. So cos beta is 12 upon 13. Are you following me?
Yes, sir. Yes, sir.
X component of P3 0, P3 is the axis. X component of P4, it is minus 100. Minus 100.
0.
You are getting this as 0. You can't say system is in equilibrium. You have to check summation Fy also. So for summation Fy, y component of P1, 85 sin alpha. Sin alpha means now 15 upon 17. Y component of P2 minus 65 sin beta. That is 5 upon 13. For P3 plus 50. For P4 0 is equal to
100.
Yes, how much?
100.
100. Right. So being summation fx is 0, you have the magnitude of resultant is 100 Newton, direction is vertical, sense is upwards. So as the resultant is not equal to 0, you can say that system is not in equilibrium. Right? Suppose if the given system is non-concurrent, non-parallel force system, general force system, then to check whether the system is in equilibrium or not, you will resolve each force into xy components. First you will find out summation fx, suppose 0. Then you will go for summation fy, suppose 0. That means the resultant force is 0. You should not conclude that the system is in equilibrium. Is it clear? Being it is general force system, you have to check for the moment also. You have to select any one point of your convenience, find out the algebraic sum of the moments of all forces about that point. If it is 0, then you can say that the system is in equilibrium. Whereas for concurrent force system, there is no portion of moment. So concurrent force system will have only resultant force. So you have to check summation Fy and summation Fx. That's all. Okay? Any doubts?